Welcome back again. We're getting into alcohols in this section. It turns out if you want to make an alcohol, what you do is take a hydrocarbon and attach an OH group to it. Anytime you have a string of carbons and then this attached anywhere really, this goes from being, well, 3 carbons originally would have been propane. When you attach an OH to it, the name changes to propanol. And just the fact that this is attached turns this from a kind of, well, a combustible fuel into an alcohol. And it changes chemical properties and makes it useful in a bunch of different ways that it wasn't before. And it changes how the naming works subtly. So, if you're used to doing chemistry, you probably see an OH and you think of the hydroxide ion, OH minus, which comes up all the time, especially in acid-base chemistry. Organic chemists, because they do everything differently, instead of a hydroxide group, they call this almost the same thing. They call it a hydroxyl group. They mostly try to make their groups or attachments end with YL. So we get methyl, ethyl, propyl. With benzene, we just learned that we get phenyl. And now a hydroxide becomes a hydroxyl group. So anytime you have a carbon chain with a hydroxyl group on it, that is an alcohol. And the name of an alcohol gets OL on the end of it. So where the 3 carbon chain that I drew in the first place here, you would have called propane. As soon as you see the OH, you go, oops, scratch that. Instead of propane, this is now propanol. Lose the E and put OL in its place. And you won't be surprised to hear it's important to say where this OH is attached. Having an OH on the tail end here is not the same as having it in the middle of the molecule attached to this carbon. So we need to give its location. And for this, of course, we want to keep the lowest number possible, so we're not going to call this 3-propanol. We're going to say it's on carbon number 1. And when I learned these, they told us to call this 1-propanol. Unfortunately, they have since changed the system and made it weirder, and so you will actually get marked wrong if you call it 1-propanol. The new improved name, I'm sorry for this, is propan 1-all. It's like with the alkenes and the alkynes where you stuff the number into the middle of the word. I think this looks bizarre, and sometimes it's awkward to say, but this is what they want. So, goodbye 1-propanol. We loved you. This is how you name your alcohols. You give the chain and then the number locations for the hydroxyl groups, and then all at the end to remind people that it's an alcohol. It is possible to have multiple hydroxyl groups on a single chain, and in that case you'll have like 2,3 or 4,8 or whatever, and on the tail end here you will be saying diol or maybe even triol to indicate that there are many hydroxyl groups. Okay, who's excited? Let's try some of these. Alright, that's a little small. Zoom in a bit. So, as usual, start with your primary. You see here, as soon as you see an OH or an HO, you know it's an alcohol, but focus on the primary. Our primary chain here is 1, 2, 3, 4, 5 carbons, and so in simpler days we would call this pentane. I'm not going to write that E because we know that gets hacked off and replaced with all. So this is pentanol. And this OH, if you count from the left, which we obviously won't, it would be on the 4th carbon. If we count from the right, it's on the 2nd carbon. So pentan-2-all, or in the old days, 2-pentanol. Here we have, that's a carbon, that's a carbon, that's a carbon. Okay, 3 carbons, our primary chain is propane. But with the OH, it's not propane, it's propanol. and the hydroxyl group is on carbon number 2, so propan-2-ol. One, two, three, four, 5 carbons in a chain. We're back to pentane. Or it would be pentane, except because of the OHs, it's pentanol, and because there are 2 hydroxyl groups, it's actually pentanediol. And where are they? If we count from this end, 3, 4, or if we count from this end, 2, 3. I'll take 2, 3, please. Pentan 2,3-diol. One, two, three, 4, 5, 6, 7 carbons in the primary. That is traditionally heptane. But the hydroxyl group makes this heptanol. And that's on the very first carbon, assuming we count from the right, which we should. So heptan-1-ol. Not too bad. Oh, branches. Or no. Okay, yes, branches, I guess. Okay, so our longest path through this, if that's our primary, that has 1, 2, 3, 4 carbons, so we want to call this butane. But it has 2 hydroxyl groups on it, so it's not just butanol, but butanediol. And both hydroxyl groups are on carbon number 2. 3 if you count from the left, but don't. We want the lower number. So butan-2,2-diol should take care of that. Okay, so our primary was the butane. We've got 2 of these on here, and don't forget we have a branch. Alcohols can have branches just like anything else. This branch is a single carbon, so it's a methyl group. We can throw in a methyl on the front of this, and since we decided we're numbering from the right, this methyl group is on carbon number 3, and so we have 3-methylbutan-2,2-diol. It just rolls off the tongue, doesn't it? It's beautiful. And this last thing, wow, it doesn't get much simpler than this. 1 carbon would be methane if it was standing by itself. Methane. But with the hydroxyl group attached, it's methanol. And what do we put for a number? Trick question. There's only 1 carbon. You don't need a number. We don't put numbers on methanol. We just call it methanol. So, not too bad. This OH, the hydroxyl group, is called a functional group because it profoundly changes how the molecule behaves. Anything with an OH on it suddenly has alcohol properties and fewer alkane or alkene or alkyne properties than it had before. So as soon as you see one of these, this is a very important feature and it changes how we think about this substance. So this is called a hydroxyl functional group. And hopefully, as you get used to looking at diagrams like this, details like an OH will start to jump out at you. They should. And we'll meet another functional group called the carboxyl group very soon. See you there.